such a good lesson today, guys. We're gonna keep talking about segments a little bit more. So 2 new vocab words, and I'm just gonna draw a segment over here so we can demonstrate on there. The first word is midpoint, and it sounds just like a middle point, only it's not just a point in the middle, it's a point in the middle. Right in the middle. It's a point that divides a segment into 2 congruent segments. That means that both of these halves have to be congruent. They have to be equal. So anytime I call something a midpoint, you're probably going to hear me say tick, tick, because those 2 sides have to be congruent because it's really in the middle. It's a midpoint. A segment bisector is kind of the same idea. It's a line, a ray, or a segment that intersects another segment at its midpoint. So if we had segment AB here, maybe I would draw a line that goes through the midpoint. That line would be considered a segment bisector. Bisect sort of means to cut in half. And so that line cuts segment AB in half. And we're throwing a little bit of algebra in again today. This says that point M is the midpoint of segment VW, and it already has the tick tick. That's a midpoint, so of course those 2 pieces are equal. And it says to find the length of segment VM. Well, the first thing you have to think about is, what does it tell me when I know I have a midpoint? And like I said, anytime I hear the word midpoint, I think tick tick. Those 2 pieces have to be equal. And that actually guides how you're going to set up your equation. Those 2 pieces have to be equal to each other. And then we're just going to solve the old algebra way. Get all the x's on the same side. It's all going to come back to you. 4x minus 3x is 1x. Keep that equal sign lined up, and I just have that 3 left over here, yeah? And then add 1 to both sides. And I get that x equals 4. Now, one thing that I always do on geometry algebra problems is I plug that back in. It's like an automatic. I'm going to plug that back in, not to the equation, but to the picture. And the reason I do that is because then I can really make sense of it. So 4 times 4 minus 1 would be 16 minus 1, 15. And 3 times 4, 12, plus 3 would be 15. Is that a good sign? I got a 15 here and I got a 15 here. And on that picture, wouldn't we expect those 2 lengths to be the same because M is the midpoint? Nice. So not only did I check to make sure my answer was correct, did you know we still haven't answered the question? It says to find the length of segment VM. So we did figure that out. We found that the length, and for length, remember, I just don't put a bar on top. The length of segment VM is equal to 15 units. So that would be our final answer for that question. Next, we're going to learn 2 formulas that actually look more confusing than they are. I'm going to try to make them simple for you. To start out, I just chose a couple of random points. I chose, this one goes 1, 2, 3, 1, 2, 3, 4. And so we call that the point -3, 4, because it goes left and up. And then this point right here, we always do our x-axis first and then our y-axis. 1, 2, 3, 4, 5. So over 5 and up 1 would be 5, 1. So I chose those random points, and I was wondering if we made a line segment that connected those 2 points, where would the midpoint go? And so I'm thinking it might be right about there, maybe a little higher. But the key is we are just going to use an average. Do you guys remember how to find the average of 2 numbers? So if we look at these 2 x values, a -3 and a 5, what's exactly halfway between -3 and 5? And one easy way to figure that out is to average those numbers. Negative 3 plus 5 divided by 2. So that would be 2 divided by 2, that equals 1. And so the exact halfway point between negative 3 and 5 is 1. Let's try that with the y coordinates. I've got a 4 here, and I've got a 1 here. So I've got a 4 on the y-axis, and I've got a 1 on the y-axis. What is right between 4 and 1? And if you want to use the math to figure that out, we're just going to average them. We add those together, 4 plus 1, and divide by 2. We get 5 divided by 2, and that's 2.5. So the halfway point here would be 2.5. And would you believe that by finding those two averages, we just found the midpoint? The average of the two x values was 1. The average of the two y values was 2.5. If we graph the point 1, comma 2.5, that puts us right here, exactly at the midpoint. How sweet is that? So we actually just used this sort of complicated looking formula up here without even really looking at it, because all the formula tells us to do is that we're going to take the two x values, add them together and divide by 2, put a comma, and then take the two y values, add them together, divide by 2. So again, that's just finding the average of the x's and the average of the y's. That's how we calculate a midpoint. Now one more formula, the distance formula. Another formula that looks really intimidating, but it'll be pretty simple. The first thing I want to do is look at this picture and think about how could I find the distance from point A to point B. I just chose those same points again. So if something is straight up and down, you can just count the squares. Or if something is straight side to side, you can just count the squares. But on this one, when it's diagonal, you can't just count to see how many squares long it is because you're counting sort of slanty. So what we're going to do is we're going to count sort of a slope type pattern, right? Rise over run. To get from that point to that point, I think we'd have to go down a ways and then right. And the question is how far down and how far right? Did you know that we're actually just looking at the x and the y values to figure that out? So if we start with these x values, we'd be going from negative 3 to 5. How far is it from negative 3 to 5? I think it should be 8, and we can count that out. Let's see. We're counting the spaces. 1, 2, 3, 4, 5, 6, 7, 8. Yep, that makes sense. And we were going from negative 3 to 5, so I think that makes sense why that would be 8 units. Let's look at the y coordinates now to figure out how far it is up and down, rise and run. This is at 4, and this is at 1. How far is it from 4 down to 1? That's 3, right? Do you guys remember the Pythagorean Theorem? Because that's really what we have going on here. Do you see this right triangle that we just made? Do you remember how that goes? It goes a squared plus b squared equals c squared. And remember that the c squared has to be the hypotenuse of the triangle, so that slanty piece that we're looking for. So we're just going to take our two lengths, and really the order doesn't make much difference, but I'll put the 8 right here. So we're going to take our 8 from that triangle and our 3 from that triangle, and those two lengths should help us determine that slanty length. Let's figure this out. 64 plus 9, 73. I'm getting, and technically plus or minus the square root of 73, but we'll use the positive version. How much is that? I got about 8.54 units. So that kind of makes sense. It should be the longest side of the triangle. So we just found the distance, but we never even touched that distance formula, right? Let's try that again, only let's try using the formula. Move that down. The formula, actually, you guys, I think the formula is more complicated than it needs to be. Whenever I write down the distance formula, here's how I write it down. I remember that it has a big square root involved, because that's what we had to do at the end of our Pythagorean theorem, is take a square root. And I remember that it kind of goes like an a squared plus a b squared. So I remember that it has a something squared plus a something squared. And then I just have to remember that in the first set, I'm going to subtract the x's, and in the second set, I'm going to subtract the y's. And I don't worry about the little 1s and 2s on there because the order shouldn't matter at all. Let's see if we can use this formula to find the distance. So first I'm going to take my two x values and I'm going to subtract them. So that was the -3 and the 5. The great thing is you can't screw up the order on this. So if I went -3 first and then -5, I would get the same answer as if I did the 5 first and then minus the -3. True story. Now the y values were 4 and 1, correct? So I'm going to take the 4 and subtract the 1. And actually, it's going to still work out for you if you do the 1 minus the 4. The reason for that is because we're about to square those, and that's why the order doesn't really matter. I've got -3 minus 5 is -8. 4 minus 1 is 3. Do those numbers look familiar to you? The -8 and the 3. We used those in our Pythagorean theorem, didn't we? I mean, it was a +8, but I'm just about to square this anyway. What's -8 times -8? +64 plus 9, 3 squared, and I still get the square root of 73. How sweet is that? And so I could leave my answer like that, or I could round it. 8.54 was to the nearest hundredth. If it was to the nearest tenth, that would be 8.5. But that was using the distance formula, both using just the Pythagorean theorem and then using the actual formula. I've got a couple of sweet challenge problems here for you. If you were to look in the book, it's going to explain this first one a little differently than I'm about to explain, but I've got sort of this little trick that you might like. I'm going to first draw a segment, and it's talking about a midpoint, so I'll stick a midpoint in there, tick, tick. And it says that 4, 1.5 is the midpoint. So you're going to have to read some of these problems carefully. 4, 1.5 is the midpoint of the point 2, -6. Did you notice I didn't even draw a graph here? It's because I'm about to use a shortcut. Is the midpoint of 2, -6 and what other point? We're trying to figure out not the midpoint this time, but the other end point. And so here's one way to do it. If you don't wind up liking this, you can look at the algebra way in the book, but check this out. If 4 is right in the middle of 2 and some mystery number, can you figure out what number would go here if we know that 4 is right in the middle of 2 and some mystery number? And some of you might have figured out that that would be 6. And the reason for that is because to get from 2 to 4, you go up by 2. And so if we keep that same pattern and go up by 2 again, we get 6. We're going to use that same technique, only thinking of the y value now. So if -6 is here and 1.5 is here, what's here? So we have to think 1.5 would be exactly between -6 and some mystery number. How far is it to go from -6 to 1.5 on a number line? You'd have to get to 0 first. So that's 6 plus another 1.5. I'm getting you'd have to add 7.5. And so, since we know that's exactly in the middle, we can use that exact same number again. Only this time we're taking 1.5 plus 7.5, and we get 9. So there's a neat way to find the answer to this problem Just kind of thinking what's in the middle. Last problem. I'm going to use some sweet algebra on this one because I don't really have a different shortcut. So here's my version of the distance formula. Remember, I don't put those little 2's and 1's down there because I just don't want to bother with them. What I'm going to do is I'm going to fill in what I know and what I don't know. This time they gave me the distance. It said the distance between this point and this point is the square root of 20. So I'm going to put the square root of 20 in for the distance here. And then I'm going to fill in, I think I know both of the x values, right? I've got the 3 here and the 5 here. So I'm going to go 3 minus 5. And then for the y values, I've got 6 minus, and there's my mystery one. So I'm just going to leave that one as a variable. I'm going to do as much as I can to simplify this and see if I can figure out what y needs to be. Okay, so I know the square root of 20 has to equal the square root of 4 plus something. So the only thing that you can add to 4 to get up to a 20 would be a 16, right? So I know that 6 minus y squared has to equal 16. Can you think of a number that you can subtract from 6 and then square it, and that would be 16? Now we could do the algebra here. We could take the square root of both sides and then subtract 6 and divide by -1, but I think you could come up with it. What if we subtracted, because 4 squared is 16, right? Couldn't y be 2 then? 6 minus 2 would be 4, and 4 squared would be 16. There's actually one other solution to this, and it has to do with the fact that if you square root both sides, you get plus or minus 4. Turns out if you took 6 minus 10, what if this were a 10? 6 minus 10 would be -4, and -4 squared is positive 16 because a negative times a negative makes a positive. So there's actually 2 different y values that could be the right answer. Are you wondering why that is? I'm going to draw you a little picture. Does that help make sense of this? We could have 2 of these same lengths right here with 2 different points, 5, 2 and 5, 10. So that's why there were 2 different answers to that problem. Those are some tricky problems. We'll do more practice, and I think you'll get really good at these formulas.